All right. Welcome to winter. Happy New Year. I see some new faces, some old faces. So it's a little bit funky the way this class runs because for undergrads, it's a second course in a two-part track of the Intro to Computer Science 1, Computer Science 2. Uh, we also get grad students who take the course as a prereq to get them up to speed in Python before they get into more of their interesting stuff here. So um, it assumes you've done a semester of Python as an undergrad. So if you're brand new to Python, it's going to take a little bit of extra work to get up to speed. Almost everyone is perfectly fine with it. And if you're a grad student, you're good at learning. And you can pick that up from there. There's a chapter in the book that's like the Python primer that sort of gives you everything we did last semester in one chapter. So we don't cover that chapter here because we had a whole other semester for the undergrads before, but it works out pretty well. So I just posted the syllabus here a couple minutes ago. Sorry, it's later than I wanted it to be. It's been a week. My wife is sick, so don't get too close to me. I seem to be fighting it off fine so far. Just a little bit congested. So we'll see. Maybe I'm next. So I hope not. All right, this is Computer Science 2 for data scientists. We teach it in Python. It's a great language. It's a 4 credit class. We have lecture twice a week and we have lab once a week here. Somehow that adds up to 4 credits. I don't really understand how that math works, but that's okay. We're here in this lovely dungeon room in the SSB with no windows, which is really sad, but it's okay. We hang out here twice a week, Tuesdays and Thursdays, 2 to 3:15. And then Tuesdays is our lab session just before lecture. So the format will be a little bit funky, but it'll work out mostly well. So most weeks we'll cover something Tuesday, something Thursday, and then the following Tuesday lab we'll practice it, and then we come to lecture 15 minutes later and we start new stuff. So should work out relatively well, give you time to practice it, do the readings, those sorts of things as we go. So our lab room is the HPEC building. It is that way there. It's the one that's connected to the really new expensive building, but not the really new expensive fancy building that has a really nice lab room, but they don't let me use it. I'm not salty. It's okay. But we're over there. It's a fine lab room. So that's our chance to practice. We do the exercises. I can look over your shoulder. You can bring your laptop up. We work on the college computers, whatever you'd like to do. Get it working. Right? That's our chance to practice. So I love classes that have lab time because it's really sad for me to teach computer classes where we don't have computers and they can't practice things. So it works out pretty well. I enjoy that. The goal with lab is you get it done before you walk out the door. But labs aren't due until the following week at 11:59 p.m. So if something comes up, you can't get it done, not the end of the world. We've got some more time to get it done here. Goes pretty well. Oh, hi, I'm Eric. Sorry, I should have probably started with this one. Nice to meet you. I am officially a Leo Lecturer 2. The university administration doesn't allow me to use the title professor. Sometimes I'm salty about that as well. Um, According to our contract, after 12 years, if I ask very nicely, turn in a lot of paperwork, then maybe they'd let me be called a teaching professor, which I'm only 2 years away from now, which is kind of exciting. But I like to be obnoxious about it because it illustrates the point that lecturers are treated differently than professors, and for some reason I'd like to point that out. So that's okay. But I'm here to paid to teach. I'm not paid to research or bring in research dollars, those sorts of things here. So I just teach classes. This is my email. You probably found that already here. Just a note, please don't use the Canvas message or email feature because everything from Canvas just goes to my spam box because I get so many Canvas notifications, I don't look at them. Like every time someone turns something in, it goes, I get an email here. Um, so if you send it from Canvas, it won't show up for me. But if you email me, it will show up. Right, so that usually works better. This is my cell phone. I don't have a desk phone here, so just use my cell phone. It's much easier. I usually have it with me. Sometimes my son likes to watch YouTube Kids on my phone, um, so I might miss you or not. But call or text basically anytime. I got to get up at 7 to take my daughter to school in the morning, and then I'm usually up till 1, 2, 3 in the morning, depending on the day here, because I like to work when my kids are in bed. Um, that's when the house is quiet, and I drink a lot of coffee throughout the day. So this holds an entire pot, which is nice. For office hours, I've got a Monday, Wednesday class that I'll be here before. My class is at 11, so I'll be hanging out in the CIS building. No one ever goes there because there's no classrooms there. It's the ugly looking building right next to the really expensive new building there. We're on the list to be renovated, apparently. I think the board even approved it. I forget where it is in that process, so thanks for paying your tuition dollars. It'll be done by the time you're long gone. But I'm sure after you graduate, we'll send you a letter saying, please donate to this school that you already gave tens of thousands of dollars to, because we're building a new building, right? I don't know. Higher ed is a little weird here. Apologies, but the whole corner of the building, the top corner, is like a shared office suite and conference room. So the lecturers have shared office space there. So I'll hang out there Monday and Wednesday, and then Thursday before our class, I'll hang out there as well. The plan to get here about 1 o'clock or so, and I'll be hanging out till about 1:55 when I wander over this way. It's a quick, short walk, and then we get here for 2. Okay. Um, if you can't make those times, that's okay. Message me. It's really quick to do a Zoom, a screen share. That works out better most of the time, and you don't have to hike over the CIS building or find me there. I can do those lots of other times, just depending on when I'm available. I got other things going on, so let me know. We can find a time that works. But part of my contract says I have to sit in the office and wait for people to come talk to me. So I sit there and wait for people not to show up. Occasionally, people show up, and that's fun because I got into teaching because I like people and I enjoy talking with people. So when I sit there, although I just get grading stuff done, which is fine. So, all right. Excuse me. The course description, this should be a copy paste from the catalog. Shouldn't be anything interesting there. The program learning goals, there's a whole thing about our accreditation process, and we're accredited through ABET, so we have to do a bunch of things. One of those things is we measure if students learn things in the program. I'm sure you're all very interested in that here. No one ever seems to care. But you can see what those goals are there for the undergrad program. And then in this specific course, we have a whole list of things that we have to cover here and that we assess if you've learned these sorts of things. Most of them aren't very interesting to talk about until we've actually talked about them, because then you know what some of these terms are here. So we'll come back to this list and look at it occasionally. Usually near the end, I look at it and be like, oh, hey, do you remember when we did these things? And kind of smile and nod. Um, you'll notice number K here. I don't know why not letter K. They're not numbered or whatever here. You will write a medium-sized program as part of a team. That means we will have a group project at the end. Yay! Everyone loves group projects. It's pairs. Really, at this point here, a pair is enough. Getting a third person in there is not all that helpful. If we have an odd number, we'll have one group of 3 and everyone else will be pairs. But generally, pairs works out best at this point here for projects. So that is not optional, unfortunately, here. So you must work with somebody, but it's a good habit. It's good practice. Being the only developer and never working with another developer, another data scientist, is really dull, because it's good to be able to bounce ideas off of other people and learn from other people. So we're going to practice it in school. We're going to have lots of group work in school, so that when you get in the industry and you do group work in the industry, you're a good team member here and you don't get fired from your team, right? Those sorts of things. I'd like to imagine college and higher ed gives you better soft skills than boot camps, where you just learn some technical things here. And that's what helps me sleep at night, because we charge you 3 times more than a boot camp, at least. All right, tools that we're going to use. So the textbook, you got a couple options. There's the Zybook here. It's not a fun interactive one, but it's just an online ebook essentially. Is cheaper than the other ebook version right from Wiley. I don't know how, or I think they got bought out. I forget. I think Wiley bought Zybooks at some point here. But they offer the book as a Zybook, which is like a subscription thing, but then you can print the chapters as PDFs to keep them here. That I think was like 50 some bucks. I'd have to look again and see. Last time I checked, you can get the actual textbook. Used is not so bad. New, they wanted like 120 bucks for this old book here. It was outrageous. So I thought this was a better deal. You can also find an ebook version of this, depending on if you're renting or buying. There's tons of different options here. And of course, if you just Google, you'll probably find a PDF out there. But the guy did a nice job writing the book here. I'm not supposed to recommend you go pirate things. So, and for you undergrads, I believe, I haven't checked in like a year or two, that this book, you take like the second half of it essentially in the 350 course, which is our data structures algorithms analysis course. So you'll use it, you will use it again, which is pretty cool. So we're going to cover the first part of it here, and then a couple other things. So that's our textbook here. I try and give examples that are not directly from the textbook. I don't even like how he does some of his examples, and I'll write the code a little bit differently, but that way you've got different ways to look at it, which is kind of fun. So you'll see my approach, you'll see his approach, and then we'll practice it in labs, and you'll do projects, and it'll be fun. We'll use GitHub, so make a free account. Please don't pay for anything here. Code, I think, does not belong in Canvas. Canvas is a terrible place to put code, and it just irritates me if code is in Canvas, because it's not very usable. GitHub makes their money selling the hosting service provider of the Git source control tool. You get a bunch of cool bells and whistles. They give away some cool perks for educational use. So we'll make lots of use of GitHub. That makes me happy. I'll show you all of that. Don't worry. That'll be our first lab. We'll practice using GitHub. If you haven't done it before, it's okay. Just takes a couple clicks. You'll get used to it. And then I'm going to use PyCharm for everything. You don't need the pro license. I would actually recommend you turn it off because at this point we don't need the bells and whistles it's going to offer. The AI autocomplete stuff is going to do more for you that you just probably won't even understand what it's doing. And then if you give me code that you don't understand, we're in for a bad time. Right? And we'll get to that in a little bit here. So if you like a different Python IDE, go for it. Some people use VS Code. Some people use, is it Spider or something? Some people like the Jupyter notebooks. Great. Whatever you'd like here, as long as you get me Python code, I'm good with it. We can figure it out. You can put all of that in GitHub and it'll be good. But I do it all in PyCharm. How you get your points in the class here. So I like a weighted system. So each of these categories is worth this percentage of your overall score. So our labs make up 15%. Essentially, if you show up and try, you will get the points, right? The goal is, and I will help you get it done, right? The goal is you've learned something, you can do it, and if you need some pointers, I'll give you the pointers, we'll get it done here. So essentially participation points here for that. I'll do quizzes pretty much every week if I remember. Occasionally I forget here, you'll have to holler at me sometimes, but I've got quizzes that I wrote off the chapters here. The goal of these is to get you to read the book, right? They're based on the chapter here. Anything I say is fair game, but anything in the chapter is fair game. They're open book, they're open notes, they're not timed. I give them so that you look at the textbook. I'm going to be completely honest here, right? It's hard to get people to do the reading sometimes. So you get points for doing the reading essentially, right? I think the quizzes were pretty easy last time around here. Same idea here. We'll have a bunch of individual projects here that are worth 25% of your overall score. We'll have one exam, a midterm exam. It's meant to be easy. I'll give you last year's exam because I have to rewrite them. Not that you folks would do it, but some people post that material on Course Hero and other sites like that, and which is actually a violation of our policy because it's not your material to distribute, but that's a whole other story anyway. But it's meant to be easy. So if the midterm is not easy for you, let's have a conversation. We'll figure out what's going on here, but that's 10%. And then the final project, your group project, partnered project, is 40% of your score. That's intentional. You cannot pass the class without the project. So if you get fired from your team because you didn't do anything, you don't pass the class. And then I'm the only one who teaches this one since 2017. You'll end up back with me again. So don't fail the class. It's bad news for everybody. Right? And then the percentage to letter grade should be pretty standard. It looks a little ugly here because the accessibility checker says I can't put it in a table like it used to be. It's fine. That should be normal. And then our tentative course schedule, outline and schedule. So the plan here, which again, we might adjust as we need to here. Course intro, GitHub, Python basics, and hopefully we'll get into Unix as well. We've got another hour, so I think we can get through all of that here. And the chapter 1 of the text is the Python primer here. Again, if you haven't touched Python before, you got some reading to do, but we'll get you there. If you've done Python before, just flip through it, just give it a little skim here. If anything looks interesting, like, oh, I don't really remember that, focus on that part here, right? That should be fine. And then we essentially take a chapter a week for the next couple weeks. So we get into object-oriented programming. We'll do a deep dive in cool stuff with object-oriented programming, looking specifically at inheritance here and polymorphism. They're fun technical terms. Don't worry, we'll get to it. This will be our first major project here. We'll start, and we'll have 2 weeks for all the projects here. So you should have enough time to work on those. The week after that, we'll get into recursion. That'll be the second project will be based on recursion. And then we'll get into array-based sequences, stacks, queues, and this is pronounced DEQ for some reason, not DQ. I don't understand, but I didn't come up with it here. And then if we need any sort of catch-up time based on how far we've gone through here, we'll do a little catch-up time. If we don't need any of that, we might push some of this stuff a little earlier. We'll just kind of see how that goes here. And then we'll get into linked lists, and then we get ready for the midterm. So before spring break, which is the first week of March, which usually it snows. I don't know why we call it spring break, but sure, it's winter break. We'll get the midterm out of the way. And then you shouldn't have anything to do until we come back here. All the projects will be done. We won't have anything done over break, so you can hopefully actually take a break and forget about school for a week, which is pretty good. Right? And then we come back and we get into a couple more advanced topics. Now, we're not going to go super deep on these because these will be things you'll do deep dives in the algorithms class here. We want to intro them, look at them at a basic level. here. So we kind of look at trees and priority queues. We'll do a whole priority queue. This is a fun structure we can do ourselves, but just sort of the basics of trees. We'll build our own map, which is really fun here. We'll look at a basic way of making maps, not some of the more advanced cool features here. We'll look at search trees. There's nice ways you can build them. We just do the basic one here. And again, you can leave the fun advanced stuff for later. We'll do some basic sorting and selection. We'll look at a couple different sorts here, a little bit more interesting ones. Um, Nothing super crazy. Again, sort of intro the topic. And then we spend a week on ethics, which is one of my favorite portions here because this is certainly important in the industry. You can do real bad things with software and with data if you are so inclined. So we'll talk about ethical use of software and data here. There's a pretty cool code of ethics you can subscribe to if you'd like through the IEEE and ACM organizations. They put together a nice one. And then the plan is the last couple sessions we'll have just set aside for your final project work time. Work with your partner here. Again, if things have to shift a little bit, we got a little bit of wiggle room here. Uh, the goal for me is you get your final project done by the end of class here, and the final exam week, you have nothing to worry about, and you can focus on the classes where people expect you to memorize crap. Right? That's not my goal. So what we're going to do instead of a final exam is you'll present your project. So all the groups will get up here and show off what they did. It usually goes pretty well. Um, low stress and good practice to get into showing off your code to a bunch of peers. Right? Hopefully that's what you'll do in the industry. Hey, look what I wrote here, and we can get some good feedback. Those sorts of things. So it takes 5-10 minutes, maybe 10 if you like to talk a lot. Most people are 5 or less to do their little demo. Ours will, a couple more things than last time. The demos will be a little bit more interesting here, um, and we'll go from there. So that's the plan for the rest of winter here. Thankfully, it'll be a little warmer by the time we're done here in April. We'll see how that goes. Questions about the tentative plan? All right, cool so far. For course-specific policies here, I'm a big stickler on academic integrity and plagiarism. People shouldn't cheat and get degrees. It's bad for everybody because if someone cheats their way through school and gets hired and doesn't know what they're doing, then that employer won't want to hire other graduates from U of M Dearborn because they think we are just a bunch of idiots. So it's in your best interest not to let your classmates cheat their way through school either. I get it. There's a lot of pressure to get A's because apparently your GPA is the most important thing about you. I've never understood that, but sure, everybody loves things to measure. So it's not hard. It's going to take time, energy, and effort, right? It's all doable. Ask me for help. I will point you in the right direction, right? I'm not going to tell you to go away, right? I'm here to help. Anybody can get a textbook and read it. Ideally, you're paying for some sort of expert advice and coaching and help along the way. I'd like to imagine that's what I do here. So come ask for help. Don't cheat. Please don't give your code to other people. I think the easy rule of thumb here is you are welcome to collaborate in English on everything in class. You can collaborate in English, okay? Not in code. Right? If you start sharing code, we've gone too far with that collaboration, aside from your team project, right? That one, obviously, you'd share code. But for the other projects, talk about it in English. That's great. Bounce ideas off of each other. I'm perfectly happy with that, right? That's okay. Talk in English. Don't share the code. All right. Chegg.com. I'm really salty about Chegg. They're a terrible site, but they're getting sued by Pearson, who I also hate because they're a terrible publisher. Just wants to take all of our money here. Hopefully they both lose. I guess the lawyers win that one, but sure. Chegg's just a terrible place. They give you the ability to upload a exam, and they'll say they'll block the exam questions for 48 hours. So they can block my exam questions showing up on their site ever. They're only going to do it for 48 hours. After that, no, screw you, Eric. Because that's how they make their money, is they let people pay to cheat and have other people answer their questions. So they've got the tools, they just refuse to do it because that's how they make their money. And it's a lot of work. I can't just ask them for their info to say, hey, which student posted my question here? I have to get my dean involved, and then that pisses off my dean because it takes their time to sign a piece of paper we have to send to them to get that information. It's a big pain in the butt. I hate Chegg. So don't go there. Don't use them for anything at all. Just stay off their site when life is good. I guess for math classes, they have answers to the even questions. And some math profs are like, hey, go look at your answers to the evens because those aren't in the back of your book. Just don't go there. Anyway, I'm well aware that ChatGPT style tools exist. They're getting pretty good. Right? They don't do everything, but at our level here, they can do basically everything we do in this class without much trouble at all here. They've gotten pretty good by now. But just like an English paper, you can't give me someone else's work and put your name on it. That's plagiarism. You can't even give me one giant quote and be like, look, here's a paper I wrote. It's 100% citation. That's not going to fly for English. That's not going to fly here. You're welcome to use the tools. I will use them and show you, hey, they're great for these sorts of things here. They'll do a couple easy things, good stuff that we can let the computer do because it's boring, right? We've done it once by hand. I'm going to let the computer do it every other time because it's terribly dull here. That's great. And I'm going to cite my source. I'm going to show you, hey, here's a code comment. Here's where I got it from. Here's my link. It works out really well here. But the bulk of your work has to be your work, right? You can't just give me, oh, I added 3 lines of code to this 500 lines that the ChatGPT gave me. That's not going to work, right? The goal is you're learning how to do this stuff here because at some point these tools fail and can't get it across the finish line. If you don't know what you're doing, you'll never get it across the finish line, right? So everyone always seems to be worried it's replacing junior engineers, junior developers. It can do most of what junior developers do here, but if we don't train junior developers and have them develop their skills and get better, we'll never have senior developers. So I think most organizations are pretty aware that you can't just get rid of junior developers and have chatbots do everything because then you'll never have senior people, right? That seems to make a lot of sense. So it can do a lot of things, but we need to learn how to use it well, right? So that goes pretty well. I don't take stuff late without prior written approval. For the projects, I will give you a solution. I'll solve it in class. So it's always due before class starts, not 11:59 p.m. I always get somebody like, oh, I thought it was due at midnight. It's like, no, look at Canvas, the due date's in Canvas. But I'll go over a solution. Most people seem to think that's worth it to see how I would approach solving it. It gives you another chance to see the project here. Goes pretty well. So I like doing that. So once I've gone over a solution, I can't take it. That usually makes a lot of sense. For the food pantry, we've got some cool friends in social sciences who looked up, learned from this guy named Maslow, and he came up with this hierarchy of needs here. Turns out most of what we do in coding turns into there's part of this like self-actualization bit of the hierarchy of needs. And if you don't have your physiological needs met, your safety and security needs met, your love and belonging needs met, your self-esteem needs met, it's really hard to do creative work. And programming really is a creative process, right? You need to engage your brain creatively to do these things here. So if you're hungry, it's really hard to do any of that stuff here. So take advantage of the food pantry, please. Reach out to them, see if there's anything to do for you. That's great. All our other university-wide policies, thankfully, are linked in Canvas. I don't have to copy paste them or read them to you because that's terribly dull here. Go check those out. All right, I think that's the syllabus. Sorry. Hopefully I didn't read too much to you. I know you're all adults who can read, but I got to pick out those highlights. Questions, thoughts, concerns? Okay. Um, excuse me. All right, for the book here then, I think I've got it in my library. These iBooks. No, goodness, I don't want that one though. This one, there we go. So there's more chapters than we get to, right, in the book here. Again, you'll get to this later half here in 350, and then you'll go a little beyond, depending on what else you tackle here. So we don't get through all of it as we go. But chapter 1 is your Python primer. Again, if you're new to Python, go check this out. Pretty much this is everything we covered in the first semester. Okay, so I'm not going to spend any time going through it here. If you've got questions, let me know. Happy to talk about it. But I think all these other ones should be fine. We didn't do a whole lot with the generators. That's okay. We'll get into that when we get there. We've done exception handling, input and output. Those sorts of things should go pretty well. So we're going to talk about GitHub here. So I'm going to make a GitHub repository, and all of the code I do in class, I'll throw in that GitHub repository. A repository is just a fancy term for folder that Git watches. Git is our source control tool. It is the most widely used source control tool out there, and it's fantastic. Thanks to our friend Linus Torvald, the founder of Linux. He used previous tools and decided they weren't good enough and he could do better, and turns out he could. All right, so when I make a repository, mine is going to be public because it's just easier to put it out there publicly. I don't care if anyone sees the code, and then I don't have to give you all individual access. I'm not going to put the code I do in Canvas because Canvas is a terrible place for code. That's a hill I'm going to die on. We shouldn't put code there. It's awful. We don't need a template here. For your projects, I'm going to use a cool tool that GitHub gives me from classroom.github.com that uses a template. It just gives you some starter files, right? But I don't need it for my repository. I'm going to use a git ignore file here and say, please don't add certain types of files to Git. Git is a source control tool, so it wants our source code, not anything we can generate. So our source code is the Python stuff we write. And there's a couple other config files and things, and our tools will generate some files. That's all great. But I don't need to add other stuff there. Now, Python's pretty slim. We don't generate a whole bunch of stuff as we go here. But other languages that are compiled, you'll take your source code, you'll compile it, and it will generate other things, bytecode and things like that. We don't need to put that into source control because you can generate it. That's the idea. Only the stuff we need to make the project goes in here. So the ignore file helps take care of that. And then for licensing, I like the MIT license because it sounds fancy, and I can tell people I have MIT license stuff. Really, that's why, because I like it. It's fancy, and people can use it with no warranty. So I'm going to make the repository. You won't have to make your own. The GitHub Classroom tool will make them for you, but I just like to talk you through the process. And now the website lets us view everything in the repository. We get a nice online viewer. So you see the git ignore file here, and it says, hey, don't add these certain things to my Git repository. Don't worry about it. We should probably never have to change this, okay? The license file is the MIT license, right? It's free of charge, as is, no warranty, right? Use it at your own risk. Pretty simple license here, works pretty well. And then the README file, because READMEs are very common and GitHub is a nice web hosting tool, anything in the README file actually shows in the README portion here. README.md for Markdown is just a Markdown file. There's specific syntax you can use for Markdown stuff, and you can edit this file, do sorts of fun things here. For your projects, I'm going to ask you to put stuff in the README file, some screenshots, and you're going to use a rubric to assess yourself and say how you did. It goes really well. You can just click the little pencil button here to edit and edit it right in the browser. You can paste screenshots in, and it does all the stuff automatically for you. It's fantastic. I like all these bells and whistles. They make me happy. So right now there's a folder, a repository online, the GitHub Cloud, right? Sure, origin, central repository. My computer doesn't have it. So Git is a distributed source control tool. So when you have a copy of the repository, you have a clone of the repository, you have a copy of literally everything in it here. So there's 5 ways to do it. I like the easy way for me. I'm going to go to this code button and say open with GitHub Desktop here. If you don't have GitHub Desktop installed, it'll say, hey, you should download GitHub Desktop. Great, go ahead and download it. Open. Now this piece says, hey, where do you want to put it, right? It's going to take this URL, this repository online, and put it here on your computer. You can put it anywhere you want on your computer. I don't care. It does not matter to me. It's your computer. The default is the documents folder in a folder called GitHub, and then the name of the repository. I like defaults because they make life easy for me. If I just keep the defaults, it just works really well here. But put it anywhere you want. Does not matter, right? If you have a Windows computer, they're going to push OneDrive on you. It probably goes into a Documents OneDrive folder or OneDrive Documents folder. It doesn't matter. It's a little slower if it's in OneDrive because a lot of files will change back and forth. And then Microsoft actually has 2 copies of it because they also own GitHub. So then it's in their OneDrive cloud and their GitHub cloud. Sure. A little bit of waste of bits there, but doesn't matter here. So I'm going to say clone. Now I've got a folder on my computer that matches the folder online. If I don't remember where I put it, you can click the Show and Explorer button here, and I can open up my File Explorer right to that location here. Hey, look, yay, great, it's here, right? And I can see the files again here. Now, you'll also see if you have your hidden files turned on, you go to View and Show Hidden Files. You probably want this on as a developer. There's a .git folder. Don't ever touch it. That's where all the Git magic happens. Just leave it alone. It's fine, okay? But that's where all that stuff happens here. I don't actually know what it even does. It's an open source tool. You can go look at the Git code here. I looked at it once and got really confused and just gave up. It was not that interesting for me. So leave that one alone. So what Git does now is it watches this folder for things to change. It's just a glorified file watcher. Sorry, I'm officially a cyborg. This is my artificial pancreas here, and it beeps at me when my sugar's bad, which is kind of important here. Still going too high. Sorry, just a second. High is okay. I get sick eventually, but low is the bad one here. So that's a fun balancing act. All right. So anything I put in this folder, the GitHub desktop client will say, hey, there's new stuff here. And what Git lets you do is make snapshots, say what is in this folder at this point in time. They're called commits. So over with PyCharm here, I'm going to make a new project. And I'm a little bit lazy here, right? Like all good developers, I'm efficiently lazy. I don't like doing more work than I need to. So I'm just going to copy this path here, because I'm going to need this in a second to tell PyCharm where to put a new project. PyCharm, this is not the fastest tool, unfortunately, here. Now that they used to have two different tools, the free tool and the expensive tool, and the free tool was faster because it didn't have all the bells and whistles. Now they just have one tool and a license that they keep like, hey, start your free trial, get 30 days free. Please use our pro license, please, please. It's obnoxious. All right. So in PyCharm, I'm going to go File, New Project. They have this little hamburger menu. Also, I sound like a boomer. I'm sorry, complaining about everything. The hamburger menu, File, New Project here. Don't put it in this folder here. It won't go in your Git repository. Right? I want it in my Git repository. So I'm going to paste in the path. You can also use Browse, but their file browser's not great here. I don't know. I don't love this one here. It's obnoxious. So I just paste in the path here. Now, for me, I'm going to put everything in one repository so you only have one link to worry about. So what I need then is folders inside of that folder. So I'm going to put a week 0 folder inside of that folder for this project. For your projects, you're going to get a new repository every project, so you don't have to have another folder inside of it. It's okay. That's fine. Now, don't check this box, create Git repository. Right? You already have a Git repository, or you will, here for your assignments here. But because Git is the most widely used source control tool out there, all of the integrated development environments know how to work with Git to be like, oh, hey, do you want a new project? Do you want it to be a Git repository? But if you put Git inside of Git, Git gets confused. I'm confused already. So just don't check the box, right? But I do like the create welcome script, right? It will generate a Python file for you. That's nice. It saves you a couple clicks. We don't have to add our own file. For this virtual environment, this is a best practice when doing development work in Python. I probably should have given you the Python download link. Sorry, you can download Python as well, or PyCharm will let you download it as well. You can download lots of different versions here. Uh, Generally, you don't want to use your computer's Python install because as we do more interesting, fun things, we're going to go install other libraries. You might not want those libraries installed on your main Python install. So a virtual environment is essentially a copy of Python that keeps everything isolated. So if we're going to add some other libraries and things from third parties, it's not going to gunk up our main install. There's a chance you clobber something by mistake if you install a bad package. It's relatively rare, but that stuff can happen. So the virtual environments are best practice. It's a little bit slow to make a copy of Python, but it's not the end of the world. It goes pretty quick. So I'm going to say create. I'm going to do it in this window. I don't need two different PyCharm windows open here. It's okay. And now I can see if I forget where I made this project here, it's in C, users, Eric C, documents, GitHub, CIS 2001, winter 2026/week 0. You can always see where your project is here. Okay. It's going to take a minute. Now it also pops up if you have Windows. Hey, do you want to exclude this from Windows Defender? Yes, I do. I don't need antivirus scanning all this stuff here. It just slows stuff down here. And this prompt, again, it knows how to work with Git. I just ignore it. I always cancel it here. We're going to use the GitHub desktop client separate from PyCharm's Git integration. It knows how to work with Git, and you can do commits right from PyCharm. I don't like doing that because then I have to do 5 different tools and remember how the 5 different tool workflows work. I just use the GitHub desktop client. Again, it works anyway here. It's not too big of a deal. So if we got it in the right spot, the GitHub desktop client says, hey, there's new stuff here. And we see a bunch of green new files. Anything in this .idea folder, just let it happen, right? That's PyCharm's folder for how it knows it's a PyCharm project. Just let it all be. But the interesting piece here is your Python code, a main.py file. Right? If you can see that, you know you got in the right spot. Now, to make a snapshot, to save this folder at this point in time, we just have to give it a little summary here. We're going to say, hey, this is week 0 started. And then we're commit here. So now my copy of the repository, my clone, has that commit. I have that snapshot, but the cloud doesn't have it. Git is a manual syncing process. You manually push your changes to the cloud or pull changes from the cloud down. We call it push and pull. That's probably a good thing because if you imagine if you're working on a team project, unlike a Google Doc where it's fine if someone's adding stuff to another paragraph, if you're writing code and 3 lines down, someone else changes what's happening, your code isn't going to run. Right? You don't want it to change on the fly. So manual sync is better for this, for our code here. Now I pushed here, so now I'm in sync with the cloud. And if I don't remember or want the URL here, I can just click the View on GitHub button. It launches out your browser back to the website, and now I can see, hey, there's a week 0 folder. You can click the folder and open it. You can click the main PY file and open it. right? It's a text viewer. We can view all these text files. We can see our Python code. And then my favorite part here is if you're having some trouble and it's not working, you can click on the line number, be like, hey, line 14 here, this URL, send this to Eric. Be like, hey, Eric, my code's not working. I'm getting an error here. You don't have to email me your Python files. You don't have to take pictures or anything. You just send me your GitHub link. And I'm super happy. I can view it on my phone. And honestly, most of the time I can figure out what's wrong from my phone. I don't even need to pull it up on my laptop. And it makes me happy. Right. If I can't, then sure, I'll go make, I can grab my copy, run it, and figure it out from there. But most of the time, just give me the URL. Life is good. Okay. That's fantastic. And what you're going to turn in for your assignments here in Canvas is just the URL of your repository. Again, we'll go all through all this in our first lab here. We'll get a lot of practice before we actually get to it in the project. We'll have some time on Tuesday to work through all of it. It goes pretty well here. All right. Um, so that's the Git repository. So let me grab a link for this and throw it in Canvas before I forget here. So all of the code I write in class will show up here. So here is our course GitHub repository. Now, I don't recommend that you guys make a clone of it because then you're going to have to be pulling changes down and you can't actually commit to my repository because you don't have permissions to it. You can see it all, you can clone it, but you can't change it, right? You don't have permission. So generally it's easiest to just go copy paste anything that you want out of here or just go look at it, right? Your own repositories you can change all you want here and that's fine, but you won't be able to change this one. So then you get out of sync rather quickly and it causes some trouble trying to resync here. It's not the end of the world, but it takes a little bit. All right, so that's a quick little Git intro. When we get to lab on Tuesday, our first lab, one half of the lab will be doing this process with the GitHub Classroom link here. So let me go set that up for you here. I'll show you what it looks like. So you won't remember for Tuesday, but it's okay. You'll have that reference here. So this one goes in my org. Here, CIS 2001, winter 2026. Now, what GitHub Classroom lets me do is give you a URL that will generate a repository for you, and it's a private repository that you have access to and I have access to, which is good. You don't want public repositories because one of your classmates might copy off of you, and if two of you turn in the same code, and I look at you funny like, how did both of you turn in the exact same code? I'm going to assume you're cheating, right? It's probably a fair assumption if your code's identical. All right, so let me make an assignment here. I'll show you what it looks like. CIS 2001. 2026. This is going to be for lab 0 here. Now, I'm going to use a template here. The reason is it will give you the ignore file and a README file. You don't have to check any of those boxes. You don't have to do any of that other stuff here. There's not anything else in the template here, but it's okay. Python template. Very good. And it's private here. There's other cool things this tool can do, but I don't bother with them. So let me go make a new lab 0. Oops, lab 0. So you'll take this URL here. No, copy the invite link. There we go. Did it copy? Did it copy? I'm so confused. Okay, it did. So please submit the URL of your repository. So you're going to interview a classmate and write on code to answer the following questions for them. Okay, so name and preferred pronouns, their major, what they do when aren't at UMD, and what's the coolest thing you've seen tech do? Okay, so that's all we're going to do here. And then we'll also please add a screenshot running to the README. Okay, and I'll walk you through what that looks like here. So what you're going to turn in is just the URL, just the website. Life is pretty easy here. And this will be due Tuesday's lab, so we do the 20th here. All right, that's all ready to go. So I'll walk you through my example of what it'll look like. And it'll be in the recording. You can reference it on Tuesday. That'll be the first half of the lab. The other half of the lab will be the Unix portion, which I'm also going to do shortly, so it ends up on the video. I don't usually video lab time because it's mostly me sitting there and just answering questions. I try not to teach anything in labs because that's your practice time, not time to listen to me. Here, you get enough of that Tuesdays and Thursdays here. So you click the link and it says, hey, do you want to accept the assignment? If you're not logged in, you'll have to log in first, right? I know I'm logged in because I see my fun little picture here. So I accept the assignment here. It will go make that repository. So now the repository will exist on github.com right here at this URL. You can click the link, takes you there. Now I need a copy on my computer. So I'm going to click the code button, open the GitHub desktop. Yes, I want to open it. I like the defaults, life is good. Now this step is important here. Make sure you pick the second option for my own purposes. So there's a small bug with the GitHub client here that if you pick this first one, you might get some errors because you don't actually have access to this thing that it's the template of. Don't worry about it. Just pick for my own purposes. If you ever forget, here you can go to repository settings, fork behavior for my own purposes and change it if you're getting that error. But it works relatively well for almost everybody. I've done it for lots of years now. All right, so now I've got a copy here. Again, I'm going to say show an explorer so that I can grab the folder here. I don't have to go browse to it myself. Go to PyCharm. I'm going to make a new project. Put it in that location here. Now, I don't need a folder inside of this folder because you're going to have a new folder for every project. You don't need to call it week 0, project 0, whatever. It's in lab 0. It's in the name already here. I like the welcome script. We're going to say create. It says, hey, it's not empty. Yes, that's fine. There's a README file and a license or an ignore file. Just make from the existing sources. Yes. I'll make it in this window. It'll generate things for me here. Just give it a second. It can see the README. Now, it opens the README. We don't need the README file open, so we can just close the README file. Give it a minute, and it will generate our main file here in a second. Should. Come on. There it goes. Here's the virtual environment. Here's my main py file. Right. If you don't get your own Python file, because you forgot the welcome script, you can always just right click and say, hey, you want a new Python file? And eventually we'll make lots of files here. We'll get through that as we go here. But we don't actually need any of this other starter stuff here. So I delete all of it. That's Control A for grab everything. I love my shortcuts. So to answer some questions, we're going to do print, parentheses, and then apostrophes or double quotes, full quotes. Either one Python's fine with here. So I'm Eric Janeski. Can't even spell my own name. That's embarrassing. I go by he and him. All right. My major is a doctoral dropout. Back in 2020, my daughter had spinal surgery for her scoliosis and she got paralyzed, partially paralyzed. Didn't go very well. I had to take care of her, and then we all got COVID and stuff sucked. 2020 was awful, by the way. Terrible time. By the time I got back here, there's a time limit on your doctoral program before you just get kicked out. Like you're just not allowed to extend beyond a certain deadline here. And my advisor, bless his heart, said, you've only got like 18 months to finish. You will not get a dissertation done in 18 months. Like I was working full time, I was teaching, and I was trying to do the school stuff. He's like, it's not going to happen. You'll spend 18 months stressing out, not get across the finish line, and be miserable. So I just quit, which was good advice, actually. Like I was a little salty about it, but no, it was really good advice here. So I don't need a doctoral degree to teach. It'd be cool. It was on my bucket list. I'd like to have one. Yeah, maybe someday when my kids are older and out of the house, I'll go back. But for now, I'm just a dropout. Essentially, all but dissertation, right? So that's a pretty popular club. There's a lot of people in the all but dissertation club, so that's fine. What do I do when I'm not here? So I teach full time at Oakland Community College, and I have 7 kids. I run marathons really just once a year. The Detroit Free Press International Marathon is lots of fun. I did it last year, got across the finish line after not training enough here, but it was lots of fun. I like that one. And then I play D&D and other games here, but D&D is a pretty common one for me. I do enjoy that. I'm sure you couldn't tell, not by my tattoos or shirt or anything. So, all right. And then the coolest thing I've seen tech do. Now, I used to work in the healthcare tech field, so most of the stuff that I saw that was cool came from healthcare tech. Yours can be anything, whatever's fine. Some people think VR is the coolest thing they've seen, which is fun. Like there's lots of cool VR stuff out there. There's no wrong answers here. But we worked in population health and health analytics here, which is really cool, looking at how do we spend healthcare dollars efficiently to manage populations to keep people healthy and out of the hospital. Because it turns out going to the hospital is really expensive, right? Treating acute illness is expensive. If we can work on preventative medicine and keeping people from getting congestive heart failure and having heart attacks, it saves everybody money, which is great. So how do we manage that as a population? What are these sorts of things that we look at? These sorts of stuff is really cool here. So like population, health analytics, some of the really cool stuff here. And it's a little bit gross, but they can actually test sewer systems to look for outbreaks of diseases. They can say, oh, hey, we can see flu is passing through the city because there's a higher trace of it in the sewage system, which is crazy. They can do that. They can test for COVID, all sorts of cool stuff they can manage at, again, at a population level. Like, hey, maybe we need to do a better job reaching out to people, getting them vaccines or flu shots or whatever it happens to be here to prevent these sorts of things. So lots of cool stuff you can do at the population level here. So that's mine. Okay. If I put it in the right spot, my GitHub client says, hey, there's new stuff here. If you didn't put it in the right spot, you just cut and paste it in. Not the end of the world. You just go find this folder. You can right click on it and say, open in Explorer. You can go cut your project out here, right? Here's all the stuff. I would just move it into the right spot here, right? That's okay. That's not the end of the world. But generally, clone the repository first, make the project in the repository, and you're saving yourself some time. But I see all of that here. So I'm going to go say, hey, here's lab 0 done. Again, the commit summary, I don't care what you put here. You'll see this on the website. So ideally, you give it good messages. I don't care what you put there. I'm going to ignore it, but you'll see it there. And then push to sync. I'm going to say view on GitHub, make sure that works. And then I probably should actually run some Python code at some point here today, right? So there's always 7 ways to do anything here. You can click the little play button here. You can right click and say run. You can go to the hamburger menu, go to the run menu, and then run. Any way you want to run should run your Python code here, and you'll get your output down below. What I'd like is a screenshot of the output. I don't need a screenshot of the code because your code will be in GitHub, right? Occasionally people give me things that don't run and I'm super confused by it. Like, why would you turn something in that doesn't even run? Like, I don't get it. So I ask for a screenshot of it running to make sure that you have at least hit the run button and something shows up on the screen, right? I feel like that's the bare minimum, but that's okay. Now to get that screenshot here, right, I see, hey, here's my lab 0 done, right? Here's the commit message that shows on the website. I can view the code if I want to see the code here. That's all great. To get it in the README, you just click this little pencil icon here, come into the README file, go down a line or two here, right? And then hit paste. And it will paste an image in, it will attach it somewhere on GitHub's cloud, do all the markdown stuff it needs to do. You say, hey, yes, we're committing this change here. Again, it's a snapshot. Let's change the README file. Here's that image here. Now it shows up. So I can see it in the README right here now, right on the website. Here's your output of it running. So for the projects, when you do self-assessments, I'll say, hey, score yourself. Tell me how you did. Here's the rubric. You get 2 points for this, 3 points for this, 3 points for that. Give me screenshots of where it does that, right? So that you can make sure you're getting the points. Again, getting people to look at the rubric and make sure that their project does what it's supposed to do. I would imagine people would do that, but I've learned over the last bunch of years teaching, it's been 14 years now, that doesn't always happen. So again, I'm trying to set you up for success as we go here. Now, you'll notice back in the GitHub client here, it doesn't show anything yet, but occasionally if you hit this little fetch button, it goes and looks for changes. It's going to say, hey, there's something you can pull because we made a change on github.com. I didn't make it locally. So there's a change that my copy doesn't have. So yes, let's go ahead and pull here to pull that change down here. And now that will change the README file back on my copy, right? So back on my copy in this little README file here, now we've got the little image here. Again, we don't see anything. It doesn't actually render it very well, but now it's been changed and we can go and edit that or however we want to, if we wanted to. Changing README locally is a pain because then you have to do your screenshots differently, right? It's much easier to just hit paste on the website and let it do its magic. All right, we okay so far? I'm talking fast, sorry. Holler at me if I'm going too fast. I drink a lot of coffee. I've been up way too much today. So the coffee helps with that. Right, so that's lab 0, first part of it here. Now we got to do the second part, all the Unix part, which is very exciting. Part of our accreditation process, one of the things they look for in engineering school is that we've taught you how to use more than one operating system. Our solution to that is to do one lab exercise in Unix in one class. Maybe later on you might do other stuff. I have no idea, but I was told I have to cover this to make sure that we're checking our box to show you you've done more than one operating system. It's very exciting. All right, all jokes aside, though, it is really cool and powerful to be able to farm work off to someone else's computer. Right? Generally, we use the cloud nowadays, but we've got a college Unix server that can do stuff here. So if you don't want all the processing to happen on your computer, you can go run it on the college Unix server, which is much bigger and beefier than your laptop, I'm sure. It has a lot more power. So to do that, we have to go connect to it. So if you have Windows 11 or Windows Terminal, you have SSH. That's the secure shell here that Mac already has with their Mac terminal. If you don't have that, you can use the PuTTY tool. The lab instructions will show you the PuTTY tool because last time I tried this on the college lab computers, they weren't up to date. Here, we still had to use PuTTY. It basically goes the same way. The command just looks a little bit different, so it's not too big of a deal. So To run SSH, now I've done this before, so it's already suggesting it for me here. You say SSH, and then where do you want to connect to? So our college Unix server, I'll have all these directions for you for lab, don't worry, I just want to demo it so you've seen it here, is login.umd.umich.edu, and then you have to tell it -L for your login, what your username is. Because by default, it's going to try and use your Windows login or something like that, and you're probably not the correct account, that sort of thing here. So I'll log in with username eCharness. That's my username. Now, when it asks for your password, this is obnoxious. You don't see any typing at all. So as I type, nothing changes on the screen here. You don't even get like blank spaces here. So if you mistype, it's really hard to know if you did it right or wrong here. Okay, I mistyped it. Uh, Come on, there it goes. And then because we've hooked into Duo, our two-factor authentication, hey, how do you want to do it here? I want to Duo push, and it will go get me logged in here. We'll say, yes, I get logged in. So now we see, hey, this is, sorry, I can zoom that in a little bit more. eCharness at my login, this little tilde sign is my home directory. So everybody has a home directory. It's your folder here. And then there's a bunch of commands you can use in Unix to do things. This is the terminal, the command prompt, the shell, whatever you want to call it here. Um, Please don't spend lots of time memorizing these things. I'll have a cheat sheet list of the commands you need. I've done them often enough here, and turns out working in the terminal actually is faster most of the time if you're familiar with it, but it's going to take a lot of learning to get there. So ls is for like list. It will tell you all the things you have here. I've got a public folder out here. I think you guys get public folders. I don't remember if that's staff only or not here. I can actually host a website out of my public page. It's not very exciting here. I haven't updated it in forever because it's a small pain. Then you have a private folder. You can make other folders. You can have files. You can have other things here. So a bunch of stuff in my folder here. Nothing super interesting, but I've got a folder named CIS 2001. That's the fun one here. So to change into that folder, to open that folder, it's CD for change directory. And then you can type it all here, 2001. Now, the current working folder here is this tilde/CIS 2001. I can see I'm in this folder here. Ls, hey, I've got a bunch of stuff here. I've done some labs before, turns out, and I never bother clearing any of the stuff out here. So let's just see, hey, can I run this Python file here? So let's say, hey, I want to run Python, and let's tell Python, please run the hello.py file. It will run that file here, and the file says, told Python to print hello world. I get that output here. If I want to see what's in the file, I can say cat here. Cat will display the contents of the file. I don't actually know what it stands for here. And the only thing in that file is print hello world. It's not a very exciting file. If you want to edit the file, you can use VI or Vim here, which is the worst text editor in the world. There's all sorts of jokes about how terrible it is and how it's impossible to exit here. Once we've done the lab, you'll be able to join the club if people understand the joke here. So it's very exciting. So we'll say VI hello.py. This is VI. This is our editor here. Okay, so I can see the contents of the file here. Okay, right now VI has two modes, and this is why it is the worst tool in the world. Some people love it. If you work in it all the time, you can get fast with it here. There's a guy who streams on Twitch, the Prime again, I think is his name, his handle. He uses it all the time, and he's ridiculously fast. It's designed so you never. They had it. This existed before mice existed, so it was designed so that you could text edit without a mouse. So you can do all sorts of really cool, fast stuff without a mouse here. So he never takes his hands off the keyboard on his stream. Like you can see his hands on his keyboard, and this guy types ridiculously fast and does some cool stuff here. I don't care that much, and I like my mouse. I like to click things, but it has two modes. It has command mode and edit mode. So by default, you're in command mode. In command mode, you can do things like save your file and quit. In edit mode, you can actually edit your file. That's why it's impossible to exit, because once you're in edit mode, you can't quit until you get out of edit mode. Okay, so to get into edit mode, you hit I for insert here. Now I can start inserting things in my file here, and I can edit around, and we can add more prints and say Happy Wednesday. Something like print isn't PI the coolest. Now to get out of edit mode here, back to command mode so I can actually close it, I have to hit escape. Escape gets rid of that thing here. Now I need to save my file. Again, I've got a cheat sheet. I should not memorize these things. I have many better things I should know off the top of my head, but for some reason I remember VI commands. So you say :S for save here. Oh no, was that wrong? Colon W for write. Thank you. Colon W for write. Okay, I did not have it off the top of my head. I tried. Uh, that's what happens. All right, now we wrote the file. Now I can do colon Q to quit here. Why colon Q to quit? I don't know. It's not my tool. I didn't come up with it. That's why it's impossible for people to exit because no one's going to remember that off the top of their head. You should not have that in your head. But again, it's fun. So now if we say, hey, Python run hello py, I get hello world, happy Wednesday, isn't VI the coolest? Very exciting stuff here. Okay, so we can write Python code, run Python code on someone else's server. Kind of like a cloud, right? But it's a local Dearborn server. Um, very fun. Now, you probably don't want to have to write stuff in VI here. Wouldn't it be nice if we could write stuff in a nice editor like via PyCharm and then just transfer files? Yes, that's the WinSCP tool here. So WinSCP lets us transfer files back and forth between our computer and another computer. Oh, look, I have lots of things I need to upgrade here. I'll do that later. Did it just totally quit? I have to, okay, it did, okay. I thought I had to upgrade here. I was scared. So what do we want to connect to here? So same thing. Oh, sorry. Need the second version here. Same connection here. login.umd.umish.edu, username, and then you just get to type your password here. Oops, that was the wrong one. Okay. There's a couple different connections we can do, but we're going to use the SFTP one, or secure FTP. Um, that one's great. And we'll say login. Yes, here's our two-factor authentication. We want to do a push. Same idea here. Make sure we're actually who we say we are. Prove. And now I see this is my computer over here, and this is my home drive over here. So I can just drag and drop stuff essentially from here to here, which is really nice. Okay, so here's my website. This is why my website's not up to date here. I gotta go update this one here. That's actually the old one here, but that's fine. That was from fall. I don't think I've updated it, yeah, since quite a while. Um, that one was just a joke here. That was fun. All right. So you can just move files back and forth this way here instead of having to edit them. So you'll do this as well, making a file here, transferring it in, and then we can go see them there as well, which is really fun. So same idea. So I can go like up a folder. That one's not. Oh goodness. Up. There we go. Up. So like into 2001, I can see all the files we did here. We can see, hey, it was last edited at this given time here, right? 2020 for that last one. That was quite a while ago. Right? And all that fun stuff. So you can actually view it this way. And then the other last little bit of fun here is if you log into the college computer, you might notice you have an H drive. Your H drive is actually connected to your Unix share as well. You can get all that stuff from your Unix share as well, right through the H drive. We just don't tell you that to the very end because then you would just drop it in your H drive instead of having to use a tool and connect in. But if you don't use a college computer, you've got to use the transfer tool like this here, and that works out pretty well. So that's the transfer tool. Yes, we want to terminate. Don't save. Yep, great. Then when you're done, we can say exit. It will connect, close your connection here. We can exit out, and we're done with that one. So that will be lab 0, part 2. Right? Part 1's using GitHub, part 2 is using Unix. Here, we'll just go through, practice some of these things here. And we'll never touch Unix again, but you know it exists. You know it's out there. You know Python actually does run on more than one operating system, which is pretty cool. It's not just stuck on Windows or just on Mac, just on Linux, right? It'll run on all sorts of stuff. On newer calculators, you can actually run Python on some of the new calculators, which is really cool here. I had to program my calculator in BASIC when I wanted to write games on it, and that took forever on a TI-83. So would be really cool to do Python. All right, so how do we do on our plan for the day? Oh, we need lab 0, part 2. We call this part 1. 1. I'll post the part 2 on Tuesday here for the Unix stuff. I don't know if anyone wants to work ahead, but we'll have plenty of time to get both those done come lab on Tuesday. And then we'll come back for lecture the following Tuesday. We'll pick up new stuff here. And we can go from there. Yeah, intro, GitHub, Python basics, Unix, great. We'll jump into object-oriented programming. We'll get into our first project. We'll have 2 weeks for that project. Project will probably be due the 27th, start a class, and we'll just keep on moving. The next project will be recursion, and we'll go, and then we'll do a project on stacks, queues, and decks. And then the last one will be on linked objects. Not technically linked lists, but linked objects here. Try and get all those done and out of the way so we can have a real spring break. I think should be the plan. Okay, awesome. Any questions, thoughts, concerns? Good. Good to see you all. I will see you next week then.